Algebra 2, this is Chapter 5, Section 6. This is the 5th video in the series. This is example 4 from the book. This seems to be the toughest thing for the Algebra 2 classes every single year. I'm not sure why, but this seems to be the absolute toughest thing to sink into your brains. So let's try this one, and I've got 4 examples for me to show you on this, basically one example. So the trick we're looking for, this is square roots. We're looking to get the radicand, or what's under our radical, to be the exact same. And hopefully that ends up the same so that we can combine like terms. So I'm looking for perfect squares because we're dealing with a square root. Remember, that's the assumed 2 right there. So I know a perfect square that would be a factor of 12 would be 4. So that would be 4 times 3. I know a perfect square that's a divisor of 27 is 9, so that's going to be 9 times 3. And I know that 48 is going to be 4 times 12, which gets us down a little bit, and 12 is actually 4 times 3, so we can go all the way down to our 3. And I'm looking at this. This one's going to leave a 3 left over, a 3 left over, and a 3 left over. Hopefully you see that. So let me go back and reduce the first one. So this is going to be the 2 on the outside, and then this 4. Let me change colors here. So the 2 is going to come down, the minus 3 is going to come down, and the plus 2 is going to come down. And then I'll grab green and write down. This square root of 4 is actually 2, so times 2, square roots of 3 is left on the inside. The 9, square root of 9 is going to be a 3, so 3 on the outside, square root of 3 left on the inside. And this one, I've got 2 4s here, so one of those 4s comes out, and the square root of 3 is left on the inside. Then I can clean this up a bit. 2 times 2 is 4 square roots of 3, minus 9 square roots of 3, plus 8 square roots of 3. From there, I'm ready to combine like terms. They're all the square root of 3, so they can be combined. So 4 minus 9 would be a negative 5, plus 8 would be a positive 3, square roots of 3. Final answer on that problem. Doesn't look like you're going to get something that simple, but you do. So most of these are just working with your radical and making sure you're very familiar with it so we can go forward to the harder stuff. You say there's harder, but yes, there is. So again, our trick is we're trying to get the same number under a radical, or as many of these terms to have the same number as possible. So I know 45 is got a perfect square of 9 times 5. 80. 80 is 10 times 8. So let me just write that down. 10 times 8, which 8 is 3 2s, and I can borrow another 2 from there. So 4 2s is 16. So this is actually 16 times 5. And then 20 is 4 times 5. Now I have it all down, so I've got a perfect square times 5, perfect square times 5, perfect square times 5. So let me rewrite the 3, the minus 5, and the plus 4, because I didn't do anything with them. And then I'll pull this out. So square root of 9 is 3, and square root of 5 is the square root of 5. Can't do anything with it. Square root of 16 is 4. Square root of 5 again is the square root of 5. And square root of 4 is 2. And square root of 5 is just, in fact, square root of 5. And I'm ready to combine my like term, or to multiply. So this is going to be 9 square roots of 5 minus 20 square roots of 5 plus 8 square roots of 5. They're all square roots of 5. Even this ugly thing is a square root of 5. Square root of 5. So I'm ready to combine like terms. So 9 minus 20 is a negative 11, plus 8 would be equal to negative 3 square roots of 5. Final answer. Okay, I've got 2 more examples to show you, and then hopefully you're kind of catching it. Why don't I break this down even further? I'll get to prime factorization here. So 12 is 2 times 2 times 3 is its prime factorization. 48. 48 is 2, which would make it down to 24, times 2, which would make it down to 12, times 2, which would break it down to 6, times 2, and then times 3. So 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 3 is 48. And then 27 is 3 times 3 times 3. So there's my prime factorizations of these. And if you want to go that far, you can. Know that I'm doing a square root, so I'm looking for groups of 2. So I have a group of 2 here, so that's 2 square roots of 3. I have 2 groups of 2 here, so that's going to be 4 square roots of 3. And I have a group of 2 right here, so that's 3 square roots of 3. And then I can bring my negative sign down and bring my positive sign down. And again, they're all square roots of 3, so I can combine them. So 2 plus 4 is 6. 6 minus 3 is equal to 3 square roots of 3. So this is another method you can do. Let me do one more with this second method. Okay, I was checking to see if I could extend the page on this one, but I can't. For some reason, that button's missing today. So square root of 3 is all I can do with that, nothing more. Let me take 72. 72 is 9 times 8, and 8 is 4 times 2. So 9 is 3 times 3 times 2 times 2 times 2. And so 8 is 2 cubed. 128, ooh, that one's a lot bigger. So 2 would make that into 64. And then 2 would make that into 32. And then 2 would make that into 16. And then 2 would make that into 8. And 8 is 2, 2, 2. So 2, 4, 8, 16, 32, 64, 128. I've got them all. Okay, 108, we just dealt with that one a few sections ago. It's going to be a 2, which is going to be 54. And then 54 is going to have another 2 in it, which is going to make that 27. And then that's going to be 3 times 3 times 3. Hopefully you've memorized by now. 27 is the 3 cubed. Okay, I'm ready to finish this problem up. Pretty close. So I can't do anything with square root of 3. I'm looking for groups of 2, so I've got a group of 2 here and a group of 2 here. So that's 1, 3, and 1, 2. So that's going to be plus 6 square roots of 2. You say, but that's not going to combine. Yep, I know. Square root of 3 and square root of 2, not going to combine there. This one, groups of 2, so I've got a 2, group of 2, group of 2. So that's going to be 2 times 2 times 2. That's 8 square roots of 2 on this one. And the last one, group of 2 and a group of 2. So that's going to be 2 times 3, which is going to be plus 6 square roots of 3. And then I need to combine like terms. So square root of 3 over here, that's one of them, plus 6 more of them is going to be 7 square roots of 3. And then I've got 6 square roots of 2 minus 8 square roots of 2. So 6 minus 8 is minus 2 square roots of 2. And that's my final answer on that one. Okay, 7 square roots of 3 minus sign, 2 square roots of 2. These are really ugly, and if you're really good at your multiplication facts and have started to memorize your perfect squares, perfect cubes, perfect fourths, these start getting easier.